Well, okay, so we will. So good evening, folks, and welcome to the McCarthy Observatory and our monthly second Saturday of the month program. Tonight I'll be talking about the state of the Earth. This is our third annual State of the Earth presentation. So we'll get going. I'm Monty Robson, the director of the observatory. And here we go. So my presentation tonight will be factual and based on real science, as accurately as I'm able to understand it. But you should know that the views that I express are mine, not necessarily the observatory's. And also, if you would please, I'm just the messenger. So you don't shoot messengers, you don't throw stuff at them. But I will ask you to put your family, your community, your nation, and the planet first, and leave political ideology out of your consideration of this presentation. This is science, not politics. Here we are. This is the wonderful, iconic picture of the full disk of the Earth taken on our last mission, manned mission to the moon, Apollo 17. The astronauts had just started on their way to the moon about an hour or so before that. This was at an altitude of about 28,000 miles. And I don't know how they could have planned such a impactful image. Look. Here, in Africa, is where science tells us our species evolved. Up here is where science tells us that our civilization evolved. The Fertile Crescent, where towns and cities came on, and the agricultural revolution. And then down here is Antarctica, which science is telling us now is melting much, much faster than they had anticipated. Now, you don't have to be alarmed at that right off. Because even if the world's temperature got as hot as they have several different predictions based on what we do. If we go on the same course we've been on for a while, they call that business as usual. And then the Earth's temperature could rise like 10 degrees Celsius, which is 18 Fahrenheit, all over the world's surface. If that happens and all of Antarctica's ice melts, that's going to raise sea level all over the world by 200 feet. In a former life, I was an airline pilot, so I know the altitude of most airports. Kennedy Airport elevation is 12 feet. LaGuardia is 21. San Francisco is 10. So, I mean, we don't need 200 feet of extra seawater. Anyway, but the other thing I want you to notice is there's nothing else. I cropped this a little bit so it would fit on the screen better, but there's nothing but black out there. This is our only home. There's no place else to go. If we continue the way we are with our Earth, our planet, the only planet that we know of for sure that has life, for now, it'll be like a high school biology experiment. You take a petri dish and have a growing medium in there, and you introduce some bacteria, and you close it up, and you can't even see the bacteria. But pretty soon they said, wow, paradise, everything we want, the perfect environment for us. What happens? They multiply like crazy. And then, just as quickly, they die off. Because they've eaten all the nutrients and they've polluted the space, and they turned it into hell. From what was paradise into hell. Anyway. So we are now in the midst of a global emergency. Climate change is what I'm going to talk about most tonight. So I won't dwell on that. Rapidly growing population. It took all of human history till 1804 for the population to get to 1 billion. And then the curve goes vertical. I was born in 1946. The population of the Earth was 2.4 billion. Now it's 7.4. In my one lifetime, the population of the Earth has tripled. Soil depletion. We need soil. It's not dirt, it's soil. We're treating it like dirt. We need it to grow our food. We're depleting it at such a rate. We're depleting it at a rate that is more than the rate the other way that the UN says we should be developing it to be able to feed the population that's coming. Species extinction. Right now, folks, we are in the midst of the 6th great mass extinction. And this one is caused by us. The World Wildlife Fund came out with their Living Planet report just a couple months ago. It comes out every 2 years. They monitor over 14,000 species of vertebrate. What they say is since 1970, in other words, 2 human generations ago, since 1970, the Earth's population of vertebrate animals has decreased by 58%. Over half the population of animals have disappeared since 1970. Natural resource depletion. So, that's important. Look, there was a time when we would mine copper, for instance. It's the same across the board. And the ore we'd be looking at was between 10 and 15% copper. And now it's down to maybe 1% or less. We can still get copper out of the earth, but we're mining stuff that they wouldn't even thought of mining 50 years ago. If a mine got down to less than 5 or 6%, they'd shut it down. So what happens when you mine 1% copper? You have to process much, much more rock. You have to disturb more of the earth to get that rock, and the leftovers that they call tailings turns into mountains of stuff. And all the while it takes much, much more energy to do that. So, deforestation, well, that's not good. Stuff that grows absorbs carbon dioxide, so that's not good, but it's happening all over the world. We're over pumping from ancient aquifers. Most of the places around here are either on town water or well water, and if we pump it out faster than it goes in from the rain, you're going to end up with not too much fresh water to drink. We're overusing fertilizers and poisons. Look, that stuff doesn't stay where it is, where you put it. The air and the water transported all over the earth. All sorts of other pollution. We're overfishing and overhunting. There's some fishing grounds that you can't fish in anymore. And we're diverting a lot of grain for livestock, which doesn't add up it'd be better to have that grain for direct human consumption than change it into livestock, and also for biofuels. So that's some of the things we're up against. But like I say, tonight it's mainly climate change. Man-made or anthropogenic climate disruption is really what it's called now, ACD. It really began with the birth of civilization 10,000 years ago. But only a minor effect. But since the Industrial Revolution, 1750, when Watt perfected the steam engine, we've been putting a lot of carbon dioxide by burning fossil fuels into the atmosphere. So here's something to think about next time you're stuck in traffic. Every gallon of gasoline you burn in your car puts over 19 pounds carbon dioxide into the atmosphere. 19 pounds a gallon. Now here's how it works. The atmosphere, including the carbon dioxide, and that's only the major greenhouse gas. Methane is a much more potent greenhouse gas. It doesn't last as long. Nitrous oxide, even water vapor. The way I look at it is any gas in our atmosphere that has more than 2 atoms in its molecule is going to absorb the carbon dioxide. So anyway, but it's opaque. I mean, it's transparent to the incoming solar radiation. So the energy from the sun hits the Earth's surface and warms it. So the Earth then tries to maintain a balance and tries to radiate this back out into space. But those atoms absorb the infrared radiation from the Earth. The solar radiation is transformed into heat, and heat radiates in the infrared, and so we continue to get warmer. We've known about that since 1824. This is not new stuff. Also, carbon dioxide stays in our atmosphere for centuries. Here's some of the risks of climate change. Global warming, yeah, well, we know that. Sea level rise, we've already experienced about a foot of it. More in some places. And then when you get a big storm like Sandy, on a full moon night, which is high tide, look what happened to New York. It's still not back to normal. Acidification of the oceans. The oceans absorb a lot of this carbon dioxide. In fact, most of it is being absorbed by the ocean. What that does is acidify the oceans. It turns into carbonic acid. So the oceans are almost 30% more acidic than they were before the Industrial Revolution started. 30%. And the life in the oceans is not used to that. They didn't evolve to that much acid. So we're getting bleaching of coral reefs all over the world. Last year was one of the worst. Species extinction. Well, plants and animals, they can move. Animals, of course, faster than plants. I don't mean a tree can get up and walk, but its seeds, the wind blows them a certain way. If they like where it is, they'll grow. If they don't like, they won't. So by changing the climate, the animals and plants that have become used to a certain ecology don't have it anymore, so they die off. Droughts, look what happened to California. Look what happened here. We were in extreme drought in New Milford from about the beginning of September until about 2 weeks ago. They finally went down a notch to severe drought. And I think with all the rain we've had recently, they'll probably knock it down another notch here in a week or so. Heat waves. Look, heat waves kill more people than all the terrorism you've ever heard of. In 2005, I believe it was, 4 or 5, a big heat wave in Europe killed 70,000. 2010, there was about 50,000 in Russia. Last summer and the summer before, summer of 2015, thousands died in India. Wildfires. Not just the American West, where there's a wildfire season. It's now much longer than it had been. But in Tennessee, that tourist town in Tennessee burned last summer. Floods, freshwater shortages, food shortages, increasing violent conflicts. Look, most people attribute the horrible situation in Syria to a major drought. They had about a 6-year drought. The farmers could not make a living and couldn't even support themselves in the country. So they moved into the city expecting the government to help them. And the government didn't help them. And so one thing led to another, and it ended up into a horrendous civil war. And human health risks. All sorts of things. A lot of them are vector-borne from mosquitoes or ticks that are extending their range northward. A lot of things to think about. So, again, the greenhouse effect, Fourier in 1824 described it. Tyndall in England in 1858 did some good experiments on it. And then Ehrenhaus in Sweden in 1896 reported some good numbers on it. There's old Fourier himself. He, 1824, published a 31-page report in a French journal about the greenhouse effect and Earth's temperature. And here it is. Annals of Chemistry and Physics, the 27th volume, 1824, and here's his paper, Remarques Generales, sure it is, I don't know how to pronounce that, but in 1836, this guy, Hitchcock, yeah. From Amherst, he got a hold of the paper, gave it to one of his tutors and said, hey, translate it. So they translated General Remarks on the Temperature of the Terrestrial Globe by Baron Fourier. And he sent it down to his friend Benjamin Silliman at Yale, who published it in 1837, in the American Journal of Science, which is still published today. Longest running scientific journal in the U.S. Now, this is a little clip from Richard Alley, who is a character, but he's a smart character. Not only is he a brilliant scientist, but he's also a brilliant communicator. So he's a member of the National Academy of Sciences and was with the Intergovernmental Panel on Climate Change, and he's a professor at Penn State. So we'll see if we can get this to go. Where are we? Come here. There we go. Those are ice cores.
So physics and chemistry tell us that adding carbon dioxide to the atmosphere warms things up. And Earth's climate history shows us there will be impacts, from melting ice sheets to rising sea level. But how do we know with equal certainty that it's not just more natural variation, that humans are the source of the increasing CO2? When we look at a landscape like this one, we know immediately that volcanoes put out all sorts of interesting things, and that includes CO2. So how do we know that the rise of CO2 in the atmosphere that we see comes from our burning of fossil fuels, and not from something that the volcanoes have done? Well, the first step in the problem is just bookkeeping. We measure how much CO2 comes out of the volcanoes. We measure how much CO2 comes out of our smokestacks and tailpipes. The natural source is small. Humans are putting out 50 to 100 times more CO2 than the natural volcanic source. We can then ask the air whether our bookkeeping is right, and the air says that it is. Volcanoes make CO2 by melting rocks to release the CO2. They don't burn, and they don't use oxygen. But burning fossil fuels does use oxygen when it makes CO2. We see that the rise in CO2 goes with a fall of oxygen, which says that the rising CO2 comes from burning something. We can then ask the carbon in the rising CO2 where it came from. Carbon comes in 3 flavors. The lightweight, carbon-12, which is especially common in plants. The medium weight, carbon-13, which is a little more common in the gases coming out of volcanoes. And the heavyweight, carbon-14. It's radioactive and decays almost entirely after about 50,000 years, which is why you won't find it in very old things like dinosaur bones or fossil fuels. We see a rise in carbon-12, which comes from plants. We don't see a rise of carbon-13, so the CO2 isn't coming from the volcanoes. And we don't see a rise in carbon-14, so the CO2 can't be coming from recently living plants. And so the atmosphere says that the rising CO2 comes from burning of plants that have been dead a long time. That is fossil fuels. The CO2 is coming from our fossil fuels. It's us.
So that explains it. So now you can tell your skeptical friends that you can explain it. And he says in other talks, hey, if you ever get a piece of evidence offered to you and you don't like it, you have a problem with it, he said discard it. There's 3,000 different independent, different types of information that says that climate change is real and it's anthropogenic. This is from the World Meteorological Organization. .2 degrees, remember that. That's the chairman of it, Dr. Tallis. So this is last year's graph. This red is 2014. Which set a record for the warmest year on record. Until 2015 came along. 2015 was much warmer than the previous years. And 2016 would be up here and probably off the chart. So the climate change is accelerating. This is I think it's Q. This is the Arctic sea ice volume. How much ice is on the northern ice cap. Measured in thousands of cubic kilometers. That's a cube of ice, a kilometer, which is 0.6 of a mile on all sides. So here's 30,000 cubic kilometers. Here's 5,000 cubic kilometers. As you can see, it's arranged by month, which is logical because the ice melts some in the summer and it grows some in the winter. It's actually the least at the end of summer, just before autumn begins, somewhere in here in the beginning of September, is the least amount of ice. And then the most of it is over here just as spring begins in March and April. So we'll put this into motion and we'll show you the volume of the sea ice on the North Pole. How it's changed from 1979 till now. Where are we? Come here. Where's my thing? There we go. Okay, ready? Okay, so you can see in 1979, this is the 20,000 cubic kilometers. Here's 10,000 cubic kilometers. What was that, about 18 maybe? And it gets down to less than 5 cubic kilometers in the summertime. So we're melting a lot of ice. In fact, I think that almost all the ancient ice has melted now. And now the ice that we're getting is just formed in the winter, and it's just seasonal. But that shows you what we're doing. And that has an effect. The ice is bright, so the solar radiation hitting it is reflected back out before it gets a chance to warm. So it'll be reflected back out past the carbon dioxide. But when the ice is not there, then the darker seawater will absorb that heat. So it's a double whammy. This was in January. Every year in January, the Bulletin of Atomic Scientists puts out what they call their doomsday clock. And it's visualized as when the clock strikes midnight, you know, like Cinderella and all that other stuff, we're done for. So they advanced it this year. It's now closer to midnight than it's been since 1953, I believe it was, when Russia exploded their first hydrogen device. So this is 48 minutes long. We're not going to watch all of it. I'm just going to show you the climate change part of it, will be presented by David Titley, who was a rear admiral for 32 years in the Navy. He was head of their climate department. He's former head of NOAA, National Oceanic Atmospheric Administration, and he's currently a professor at Penn State. So, I mean, if he doesn't know about it, no one does. So where's my thing? Here we go. So bear with me while I advance it to
Good morning.
his portion.
Good morning.
Yeah, whoops. That's Ambassador Pickering, who's a famous diplomat over the years. There we go.
So long as carbon dioxide continues to be pumped into the atmosphere, irrespective of political leadership. The current political situation in the United States is of particular concern. The Trump administration needs to state clearly and unequivocally that it accepts climate change caused by human activity as reality. No problem can be solved unless its existence is first recognized. There are no alternative facts here. So let me just go through a few of the specifics that cause the board to remain concerned and continue concerned about climate change. While global efforts to limit climate change have ultimately produced mixed results over the past year. The Paris Agreement did go into effect in 2016, and countries are taking some actions to bring down emissions of greenhouse gases. There are also encouraging signs that global annual emissions were flat this past year in 2016, although right now there is no assurance that this heralds a breakpoint. Continued warming of the world, unfortunately, as measured in 2016, underscores one clear fact. Nothing is fundamentally amiss with the scientific understanding of climate physics. Human activity is the primary cause of climate change, and unless carbon dioxide emissions are dramatically reduced, global warming will continue to threaten the future of humanity. 2016 was the warmest year on record, and it broke the record of 2015, which broke the record of 2014. In fact, 16 of the 17 warmest years on record have been recorded since 2001. This is much longer than any one period of El Nino or La Nina or any other oscillation. For local effects in the United States, we have seen catastrophic floods in Houston, Baton Rouge, along the Texas-Louisiana border, North Carolina, Ellicott City, Maryland. The rain bombs continue. At the North Pole, we have experienced this past winter multiple occasions in which the temperature has been at or near freezing. This is about 30 to 40 degrees warmer than an average case, and this happens again and again. More and more of the research in Greenland and Antarctica point to greater and faster sea level rise. Our intelligence community in September of 2016 highlighted 6 impacts of the threat of climate change: stability of countries, heightened social and political tensions, adverse effects on food prices and availability, increased risk to human health, the negative impacts on investments and economic competitiveness, and potential climate discontinuities and secondary surprises here. Unfortunately, in 2016, the international community did not take the steps needed to begin the path towards a net zero carbon emissions world. The Marrakesh Climate Change Conference, for instance, produced little progress beyond the emissions goals pledged at Paris. As mentioned, the political situation in the United States is of particular concern. The Trump administration has put forward candidates for cabinet-level positions who foreshadow the possibility that the new administration will be openly hostile to progress towards even the most modest efforts to avert this catastrophic climate change. Climate change should not be a partisan political issue. The well-established physics of the Earth are neither liberal nor conservative in character. The international leaders need to refocus their attention on achieving the additional carbon emissions and carbon emission reductions that are needed to capitalize on the promise of the Paris Accord here. In summary, the United States, as a very first step, needs to make clear, unequivocal statements in the Trump administration that it accepts climate change. It's caused by human activity as a scientific reality. Alternative facts will not make the challenges of climate change magically go away. Thank you very much.
So, I'm not going to read all of this because I showed you the video. I'll just read you some of it. First of all, this is their statement that was issued on the 26th of January, along with the press conference. It's addressed to leaders and citizens of the world. That's us. Here's the next to the last page. And again, I'm not going to read it all, but I'll read some. Because we know from experience that governmental leaders respond to public pressure, we also call on the citizens of the world to express themselves in all the ways available to them, including through the use of the powerful new tools of social media, to demand that governments around the world sharply reduce their country's greenhouse gas emissions and fulfill the Paris Accord promise of keeping warming to 2 degrees Celsius above pre-industrial levels or less. This temperature target is consistent with consensus views on climate science and is eminently achievable and economically viable, provided that poorer countries are given support they need to make the post-carbon transition, and to demand that the Trump administration acknowledge climate change as science-backed reality and redouble U.S. efforts to limit carbon dioxide emissions and support carbon-free energy sources, including, when economically reasonable and safe over the long term, nuclear energy. It's well past time to move beyond arguments over the reality of climate change and on to solutions, including fiscal measures such as carbon markets and carbon taxes or fees that encourage efficiency and put a price on carbon emissions. So keep in mind that what this respected group is telling us is that the citizens of the world, us, to express themselves in all the ways available to them. That says it's pretty serious. Anyway, on Saturday, April 29th, people all over the United States and the world are going to march for the climate. The main march will be in Washington. Here's the schedule. If you care, 11 a.m. they're going to meet in front of the Capitol. 12:30 they'll march up Pennsylvania Avenue. 1:30 they'll surround the White House on all sides. And then at 3 they'll reconvene at the Washington Monument Grounds. So I think they might be expecting some problem here. Sounds like they're going to surround the White House and run down to the monument to get away from the whatever it is. But in New Milford on Saturday the 29th, the march will be at the New Milford Green at noon. If you want to go into New York, it'll be in Washington Square Park, also at noon. There's one in Ridgefield. I think it starts at 10. There's one in New Haven, one in Greenwich, several in adjacent New York. So if you don't have other obligations, it might be nice to show you support the climate. So the big People's Climate March, the Washington one they're expecting will be bigger, but was in New York in September 2014. And so this clip was put out by I'll remember her name in a minute. You can see it in the credits. Lear, Norman Lear's wife. But it was presented to world leaders at the UN Climate Summit in New York. It was made specifically for them, and it's really it's a lot more optimistic than I am, but hopefully it'll leave you with a good feeling.
One day, we will wake up to find that the energy that powers the alarm clock came from the breeze through the trees the night before. And we will go to work that morning riding the rays of the sun. It will light our cities and power our businesses. It will warm our homes and cool our workplaces. It will reduce sources of conflict and fuel our economies. It will connect us all. It won't scar the land or poison the seas. The food we eat will be good for our bodies and good for the planet. And the weather that day won't make us worry for tomorrow. There will be more jobs and less disease. The sea level will stop rising. And species will stop dying. The question is, how do we get to that day from where we are today? All 7.3 billion of us. We start by deciding that beyond our doubts and differences, such a day truly exists. And that is something each of us can do today. We can make today the day we stop thinking that the changes required to get there are impossible and beyond us, and start realizing that they are not only possible, but what the future requires of us. We must stop turning from the warnings of science and fear and denial, and instead turn toward the solutions and partnerships we need. We can make today the day we stop pointing at each other in blame, and instead chart a new course together. We have never faced a crisis this big, but we have never had a better opportunity to solve it. We have everything we need to wake up to a different kind of world. We need our leaders to be brave and their choices to be bold. They will either remember us as the generation that destroyed its home, or the one that finally came to respect it. We have every reason in the world to act. We can't wait until tomorrow. This is our only home. You can choose today to make a world of difference.
You ever seen such good-looking youngsters? Lynn Lear. So, anthropogenic climate disruption can only be slowed or stopped if all of us work toward that goal. We need to educate ourselves about the issues, discuss it with anyone that you can, write, email, or call our government representatives. We need to get out in the streets and protest for the earth. We need to be as kind to the environment as we can in our daily lives. So if anyone's interested, I'll be teaching a climate change course starting April 18th at the high school here. And if you want further information or to enroll, you do it through the adult education office at the high school. And if anyone's interested in starting a climate change discussion group or action group, please contact me. That's me, Monty Robson, no dots or anything, at Gmail. So that's all I have. Thank you for coming and for putting up with me and not throwing things.